Hi there, welcome to another informative lesson with ExamPadi. Today's topic is linear inequalities, part 1. And in this lesson, we will discover ways to identify and solve linear inequalities in one variable. Come along with me. Let's start by imagining a scenario where a mother and a child have different ages. The difference in their ages is referred to as inequality. Now, think of a linear inequality as a balanced scale with two sides. Each side can be greater than, less than, or equal to the other, just like in a real-life balance scale. Linear inequalities is a mathematical concept that might seem tricky at first, but trust me, it's quite straightforward. A linear inequality contains at least one linear function, also known as a polynomial of degree 1, compared with another algebraic expression of degree less than or equal to 1. What then is the definition of linear inequalities? A linear inequality is a statement that compares two expressions using greater than, less than, greater or equal to, or less than or equal to symbols. Consider a scenario where a mother and a child have different ages. The difference in their ages is what we call inequality. This lesson delves into the use of inequalities in arithmetic, algebra, and even in our everyday lives. It also introduces inequality symbols and critical tools for understanding and working with inequalities. Let's take a look at a few examples. Greater than, less than. The sum 5 plus 3 equals 8 is a simple equality. However, as we know, quantities are often not equal. For example, 5 plus 5 doesn't equal 8. Where not equal means is not equal to. We can also write 5 plus 5 greater than 8, where the symbol means is greater than. Similarly, we can write the following: 3 plus 3 does not equal 8. 3 plus 3 less than 8, where the symbol means it is less than. The symbols greater than, less than are inequality symbols. They are used to indicate that quantities are not equal. The symbols greater than and less than are more informative than not equals to. They provide additional information about the relationship between the quantities. For instance, x doesn't equal 0 tells us that x is not equal to 0, meaning it can be any positive or negative number. On the other hand, x less than 0 tells us that x is less than 0, indicating that x must be a negative number. The symbols can be used to change word statements into algebraic statements. For example, the distance between the two villages is over 18 kilometers. How do we write this as an algebraic statement? Let the distance between the villages be d kilometer. Then we can write d greater than 18. A statement like d greater than 18 is called an inequality. Let's apply the concept of inequalities to a real-world scenario. Imagine Shade has X naira. She spent 200 naira and she has less than 50 naira. We can represent this situation with an inequality in X. Shade spent 200 naira out of X naira. Thus, Shade has X minus 200 naira left. We can write this as X minus 200 naira less than 50. The second symbol we'll be looking at is not greater than not less than. Most towns have a speed limit of 50 km per hour. If a car traveling at S km per hour is within the limit, then S is not greater than 50. If S is less than 50, or if S is equals 50. The speed limit will not be broken. This can be written as one inequality, that is, S is less than or equal 50, where the symbol means less than or equal to. Thus, not greater than means the same as less than or equal to. In most countries, voters who participate in elections must be at least 18 years of age. An individual who can vote is A greater than 18 or A equals 18. This can be written as one inequality, that is, A is greater than or equals 18, where the symbol means is greater than or equal to. Thus, not less than means the same as greater than or equal to. Let's explore graphs of inequality. Inequalities like 3x greater than minus 12 and 2x minus y less than or equals to 7 have unknowns or variables with an index of 1, that is, x equals x raised to the power of 1 and y equals y raised to the power of 1. We already know that anything raised to the power of 1 is that same thing. Inequalities with variables of index 1 are called linear inequalities. They are also known as inequalities on a straight line without no numerator or denominator. Inequalities like 3x greater than minus 12 and 2x minus y less than or equals to 7 have unknowns or variables with an index of 1, that is, x equals x raised to the power of 1 and y equals y raised to the power of 1. Inequalities with variables of index 1 are called linear inequalities, that is, inequalities on a straight line without no numerator or denominator. 3x greater than minus 12 is a linear inequality in one variable x. 2x minus y less than or equal to 7 is a linear inequality in two variables, x and y. This lesson is restricted to linear inequalities in one variable. This lesson is restricted to linear inequalities in one variable. When working with linear equations involving one variable whose highest degree or order is 1, you are looking for the one value of the variable that will make the equation true. But if you consider an inequality such as x plus 2 less than 7, then the values of x can be 0, 1, 2, 3, any negative number, or any fraction in between. In other words, there are many solutions for this inequality. Fortunately, solving an inequality involves the same strategies as solving a one variable equation. So even though there are infinite answers to an inequality, you do not have to work any harder to find the answer. To review how to solve one variable equation. However, there is one major difference that you must keep in mind when working with any inequality. If you multiply or divide by a negative number, you must change the direction of the inequality sign. You will see why this is the case soon. Let's go back and look at x plus 2 less than 7. If this were an equation, you would only need to subtract 2 from both sides to have x by itself. That is, x plus 2 minus 2 less than 7 minus 2. Plus 2 minus 2 gives 0. 7 minus 2 is 5. Our final answer is x less than 5. Remember that the new rule for inequalities only applies to multiplying or dividing by a negative number. You can still add or subtract without worrying about the sign of the inequality. But what would happen if you had minus 2x greater than or equals to 10? Before solving, if you let x equals minus 5 or minus 6 or any other value that is less than minus 5, then the inequality will be accurate. So, you would write your solution as x less than or equals to minus 5. In the process of solving this inequality using algebraic methods, you would have something that looks like the following. Minus 2x divided by minus 2 greater than or equals to 10 divided by minus 2. Minus 2 would cancel minus 2. Minus 2 in 5 is minus 5. Therefore, there will be a change in sign. As said earlier, our final answer will give x less than or equals to minus 5. Let's take a look at a few examples. 1. 2x plus 3 greater than minus 11. Begin by getting the variable on one side by itself by subtracting 3 from both sides. Or you can as well collect like terms. 2x plus 3 minus 3 greater than minus 11 minus 3. Plus 3 minus 3 equals 0. Minus 11 minus 3 is 14. I believe by now you should be able to add two numbers having negative signs. It simply means you are owing 11 naira and you still borrow another 3 naira. Altogether, you are owing 14 naira because minus sign means owing. 2x greater than minus 14. Then divide both sides by the coefficient of x, which is 2. Therefore, we have 2x divided by 2 greater than minus 14 divided by 2. Since you are dividing by a positive 2, there is no need to worry about changing the sign of the inequality. Remember, the symbol only changes when dividing with a negative sign. Therefore, our final answer is x greater than minus 7. 2. 4 minus 3x greater than or equals to 20. The solution to this problem begins with subtracting 4 from both sides or collecting like terms. 4 minus 4 minus 3x greater than or equals to 20 minus 4. 4 minus 4, 0. 20 minus 4 gives 16. Therefore, we are left with minus 3x greater than or equals to 16. Divide both sides by minus 3. Therefore, we have minus 3x divided by minus 3 greater than or equals to 16 divided by minus 3. As soon as you divide by minus 3, you must change the inequality sign. Our final answer will be x greater than or equals to minus 16 over 3. 3. 5x minus 7 greater than 3x plus 9. This solution will require a little more manipulation than the previous example. You have to gather the terms with the variables on one side and the terms without the variables on the other side, which is simply known as collecting like terms. 5x minus 3x greater than 9 plus 7. 5x minus 3x gives 2x. 9 plus 7 equals 16. 2x greater than 16. Divide both sides by 2. 2x divided by 2 greater than 16 divided by 2. Our final answer is x greater than 8. There is another type of inequality called double inequality. Double inequality is when the variable appears between two inequality signs. This is a shortcut way of writing two separate inequalities into one and using a shorter process for finding the solution. What are the basic rules of inequalities? Rule number 1. If A is greater than B, then B is less than A. If A is less than B, then B is greater than A. Rule number 2. If A is greater than B and B is greater than E, then A is greater than E. For example, if 6 is greater than 4 and 4 is greater than 2, we can then say that 6 is greater than 2. If A is less than B and B is lesser than E, then A is lesser than E. For example, if 3 is less than 7 and 7 is less than 10, then 3 is less than 10. Rule number 3. If A is greater than B, then A plus E is greater than B plus C, or A minus C is greater than B minus C. If A is less than B, then A plus E is less than B plus C, or A minus C is less than B minus C. That is, we can add to or subtract from both sides of an inequality the same quantity without changing the sign of the inequality. Rule number 4. If A is greater than B and C is a positive number, that is, C is greater than 0, then AC is greater than BC and A over C is greater than B over C. If A is less than B and C is greater than 0, then AC is less than BC and A over C is less than B over C. What this simply means is both sides of an inequality can be multiplied or divided by the same positive number without changing the sign of the inequality. Rule number 5. If A is greater than B and C is negative, that is, C is less than 0, then AC is less than BC and A over C is less than B over C. If A is less than B and C is less than 0, then AC is greater than BC and A over C is greater than B over C. Note, both sides of an inequality can be multiplied or divided by a negative number, but the sign of the inequality is reversed. The sign of inequality is changed if both sides are multiplied or divided by the same negative number. Rule number 6. If A is greater than B and C is greater than D, then adding the inequalities A plus C greater than B plus D. If A is less than B and C is less than D, then A plus C is less than B plus D. That is, inequalities having the same sign can be added side by side to each other without changing the sign of the inequalities. Rule number 7. If A is greater than B and C is greater than D, either A minus C greater than B minus D or C minus A is greater than D minus B is true, but not the two are true at the same time. Similarly, if A is less than B and C is less than D, then either A minus C is less than B minus D or C minus A is less than D minus B is true, but not the two. Rule number 8. If A is greater than B and B is greater than 0, and C is greater than D and D also is greater than 0, or A is less than B and B is less than 0, and C is less than D, D is less than 0, then AC is greater than BD. Rule number 9. If A is greater than B and N is greater than 0, then we can say A raised to the power of N is greater than b raised to the power of n. For example, 5 is greater than 3 and 2 is greater than 0. Therefore, 5 square is greater than 3 square because 5 square is 25 and 3 square is 9. If a is greater than b and n is less than 0, then a raised to the power of n is less than b raised to the power of n. If a is less than b and n is greater than 0, then a raised to the power of n is less than b raised to the power of n. If a is less than b and n is less than 0, then a raised to the power of n is greater than b raised to the power of n. For example, 4 less than 6 and minus 2 less than 0 simply means 4 raised to the power of minus 2 greater than 6 raised to the power of minus 2. That is 1 over 16 greater than 1 over 36. You can simply prove this using your calculator. 1 divided by 16 greater than 1 divided by 36. Compare them using their decimal answers. Let's explore more examples. 1. Minus 2 greater than 6 minus 1 greater than 10. The strategy for solving this inequality is similar to other examples, except in this case, you are trying to isolate the variable in the middle rather than on one side or the other side. But in the process of getting the x by itself in the middle, you should add 1 to all 3 parts of the inequality. That is, minus 2 plus 1 greater than 6 minus 1 plus 1 greater than 10 plus 1. This will result into minus 1 greater than 6x greater than 11. Then divide each entity by the coefficient of x, and the coefficient of x is 6. So we have minus 1 over 6 greater than 6x over 6 greater than 11 over 6. There we have minus 1 over 6 greater than x because 6 will cancel out 6 greater than 11 over 6. Our final answer is minus 1 over 6 greater than x greater than 11 over 6. We can also solve the question above using another method. In this case, we can split the inequality into a left-hand side and right-hand side equation and then solve simultaneously. For example, minus 2 greater than 6x minus 1 greater than 10. Minus 2 greater than 6x minus 1 on one side, that is on the left-hand side, and 6x minus 1 greater than 10 on the right-hand side. Remember, you are solving both simultaneously. Collect like terms on both sides. We have minus 2 plus 1 greater than 6x on the left-hand side, and we have 6x greater than 10 plus 1 on the right-hand side. Minus 1 greater than 6x on the left-hand side, 6x greater than 11 on the right-hand side. Divide both sides by the coefficient of x, both on the left-hand side and on the right-hand side. Minus 1 over 6 greater than 6x over 6 on the left-hand side, 6x over 6 greater than 11 over 6 on the right-hand side. On the left-hand side, 6 will cancel 6. We are left with minus 1 over 6 greater than x. On the right-hand side, 6 will also cancel 6. We are left with x greater than 11 over 6. After finding the value of each inequality respectively, we can now merge the two results without repeating the variable x. Therefore, merging the two results gives us minus 1 over 6 greater than x greater than 11 over 6. We have come to the end of today's lesson. Here are a few questions to assess yourself. 1. Write either greater than or less than instead of the words. A. 6 is less than 11. B. Minus 1 is greater than minus 5. C. 0 is greater than minus 2.4. D. minus 3 is less than plus 3. E. X is greater than 12. Number 2. State whether each of the following is true or false. A. 13 greater than 5. B. 19 less than 21. C. minus 2 less than minus 4. D. minus 15 greater than 7. E. 3 plus 9 less than 10. 3. Solve the following inequalities. A. X minus 2 less than 3. B. X plus 3 greater than or equals to 6. C. A plus 5 greater than 7. And D. Y minus 3 less than or equals to 5. Thank you for learning about linear inequalities with me today. I believe you've learned something. See you in our next video.